Hi guys, until now we have seen about the bodies which are at rest. So we have seen about statics. But according to definition of mechanics, it is the study of bodies which are at rest and which are in motion. So the bodies at rest, the study of bodies at rest is called statics, and the study of bodies which are in motion is called dynamics, right? And dynamics is divided into kinematics and kinetics. Kinematics is the one which is the study of bodies without referring to the forces causing the motion. That means we do not consider the forces which are causing the motion. Whereas in kinetics, we consider the forces which are causing the motion. So in today's uh, in today's lecture, we will see about kinematics. So we will see about kinematics, that is without considering the forces that are causing the motion. So some terms which are used in kinematics are displacement, velocity, and acceleration. The terms like force, work, energy, these are not considered in kinematics. So let us see what is displacement, velocity, and acceleration. So what is motion? Traveling traveling a body from one place to another place is called motion. So for example, a body from 1 travels to 2. It can be traveled from any path like this, or in a straight line. So the distance, this is called the distance. This is also called as distance. This shortest distance is called displacement, which is represented by S. Displacement is represented by S. So in order to travel from one point to another, time is required, right? Time is required to travel from one point to another. So in what time the displacement is covered by this body is called velocity. So velocity is equal to displacement divided by time. In how much time the body is taking, in how much time the body is taking to travel from one point to another. This is called velocity. So velocity is given by displacement divided by time. It is represented with V, and displacement is represented with S. So time is represented with T. So this is called average velocity. This is average velocity because the body may travel with same velocity or uh, different velocities. Suppose it can travel with velocity some v1 and with velocity v2 here and v3. Like that, it can travel with any type of velocity. So this is the average velocity, total distance divided by total time taken by the body to reach from 1 to 2. So there is another one called instantaneous velocity. What is instantaneous velocity? The body may travel with acceleration or deceleration or whatever it may be. At particular point, see, this is point 1, this is 2. The body may travel with an increasing acceleration. What is acceleration? The rate of change of velocity is called acceleration. So slowly, first let us say it starts with a velocity 1 meter per second, and on reaching to, let us say, 4 meter per second. So as the distance is increasing and the time is increasing, the velocity is increasing. If we consider a particular point and we need to find the velocity, that is called instantaneous velocity. In order to find instantaneous velocity, we take a small section which is, this distance is delta s and the time is delta t. So this small distance delta s is traveled within the time delta t. So what is instantaneous velocity? It is a particular point, and it is not a particular distance, it is a particular point. So the velocity with which the body travels in this small distance delta s is delta s by delta t. So what is instantaneous velocity at particular point? So at particular point means this delta t should tends to 0 so that we obtain the certain point. So limit delta t tends to 0. So this is the definition of a derivative, right? It will be studied in calculus. So limit delta t tends to 0, delta s by delta t gives ds by dt. So what is it referring to? Rate of change of displacement is called velocity. Rate of change of displacement. So we have seen the velocity is increasing from point 1 to 2, and we have found at particular instant the instantaneous velocity. So velocity is increasing, which means velocity is changing with time. So this change in velocity is called acceleration. So acceleration is given by, it is represented by small a, and rate of change of velocity is acceleration. So this is rate of change of velocity. Rate of change of velocity is acceleration. So acceleration can be represented in other dv by dt, and also, so what is v? V is ds by dt, right? So d by dt of v is ds by dt. So it will become d square s by dt square. D square s by dt square. And it also can be represented as acceleration is equal to dv by dt, right? Multiply and divide it ds by ds. So it will become dv by ds into ds by dt. So ds by dt is velocity v, dv by ds. So remember this. And the next one is, if the body travels in a horizontal position, or some like, if a body travels in vertical, if a body travels in horizontal, whatever it may be, if the velocity is increasing, it is said to be acceleration. If the velocity is increasing in vertical direction and it is due to gravity, it is said to be acceleration due to gravity. So let us see acceleration due to gravity. So if there is a building like this, and this is first floor, this is second floor, this is third floor. If you throw a body from here, it reaches with a velocity say 10 meter per second. And if you throw from second floor, it reaches with more than 10 meter per second. And if you throw from third floor, and more than, for example, say here 20 meter per second, here say 30 meter per second. So by increasing the distance, the velocity with which it is reaching the ground is increasing, which means the velocity is increasing by the travel distance. So velocity is increasing, which means the body is accelerating. So acceleration exists while uh, throwing a body down, because this is due to gravity. So Newton's law of gravitation, what does it state? Every body attracts every other body, and it is directly proportional to the force of attraction is directly proportional to product of masses, and it also directly proportional to square of distance between them. So this we have seen in the first chapter, right? So removing proportionality, we get universal gravitational constant G. So the force of attraction is equal to universal gravitational constant multiplied by product of masses divided by square of distance between the two bodies. So if you consider m1 as small m, which is the mass of body, and m2 as capital M, which is mass of earth. Mass of earth is 5.972 into 10 power 24 kg, and small r as radius of earth, which is at poles it is 6356.4 kilometers, and at equator it is 6378.37 kilometers. Why? Because the earth is in the oval shape, right? In this shape. So this is equator, and these are poles. This is equator and these are poles. So, and the force of attraction. Force of attraction means the weight of the body, right? What is weight of the body? The force with which the earth attracts the body is called weight of the body, which is equal to m into g, because force is equal to force is mass into acceleration. Here the acceleration is due to gravity, and it is small g. So the force of attraction F is equal to W, right? So W is equal to G into M1 is here small m, and M2 is capital M, and divided by R square. So W is equal to mg, right? Here m small m gets cancelled, and G is equal to Gm divided by R square. So what is the value of G, universal gravitational constant? G is 6.67 6.674 into 10 power minus 11. What are the units? Newton meter square per kg square. Newton meter square per kg square are the units of universal gravitational constant. If we substitute all the values in this, we get G value as G is equal to 9.86 meter per second square. This is at poles. And at equator, G will be 9.797 meter per second square at equator. So as a standard value on earth, we take G as 9.81 meter per second square. What does this mean? For every second the body increases a velocity of 9.81 meter per second. So 9.81 meter per second is increased for every second. This is acceleration due to gravity. So next let us see So what is kinematics? The kinematics is the one which deals with the bodies in motion without referring to forces, right? So motion can be rectilinear, curvilinear, or circular. So what is rectilinear? The body travels from one point to another. It can travel in a straight line. This is called rectilinear motion. It can travel in a curved line. This is curvilinear motion. And a body can travel from its own point to, again it can return to its point. It is called circular motion. So let us see motion, these types of motion one by one. So first one is linear motion. What is linear? Rectilinear, or simply it can be called as linear motion. Linear motion is the one which travels in a straight line. So in linear motion, the motion can be uniform motion and non-uniform motion. What is uniform motion? If it travels with a constant velocity, it is called as uniform motion, and it travels with a changing velocity, it can be called as non-uniform motion. Okay. There are some important curves which are asked in GATE exam. It will be asked like this. You will be given 4 types of curves, and it will be asked to find which one of the following is the uniform motion curve, like that. So in displacement time curve, time is plotted on x-axis and displacement is plotted on y-axis. In uniform motion, the body travels with constant velocity. The body travels with constant velocity. So as the time increases, the displacement also increases. Is directly this. That means for every second the displacement is same. In 1 second, if the distance traveled is 1 meter, and in second also the distance traveled is 1 meter, and in third second also the distance traveled is 1 meter. So this will be a straight line. Displacement time curve for uniform motion will be a straight line. In non-uniform motion, the displacement is changing with respect to time. As the velocity is changing with respect to time, the displacement also changes with respect to time, as velocity is a function of displacement only. So in this, if we take a point here, and if the slope at this point is found out, this is theta, and it will be ds by dt. Rate of change of displacement is called the slope in this displacement time curve, but this ds by dt is equal to velocity. So velocity is equal to ds by dt, and ds is equal to v into dt. Integrating on both sides, we get s is equal to integral v dt. So next one is velocity time curve. In uniform motion, the velocity will be constant, right? So whatever may be the time, the velocity will be constant. So this is a horizontal straight line. And in non-uniform motion, as the time increases, velocity also increases, because it is non-uniform velocity. So if we find a slope here, let us take this point. And the slope of this curve at this point is, this is theta, which is equal to dv divided by dt. Rate of change of velocity is called acceleration, right? This is acceleration. So acceleration is equal to dv by dt, which is slope of the line at any particular point. And also dv is equal to a into dt, right? So v is integral of a into dt. So if you find the area under this curve, it gives displacement. Area under this curve gives the displacement. Here acceleration is dv by dt, which is theta, and ds by dt is velocity, and in the last graph we have seen s is equal to integral v into dt. So v into dt, what is v into dt? This is dt, right? And velocity at this the section we take is v. So v into dt is the area of this section. If we extend this v into dt from t1 to t2, we get the area under this curve, and it is equal to this displacement. So area under vt curve gives displacement, and slope of curve gives acceleration. Slope of curve gives acceleration. So next one is acceleration time curve. In uniform motion, the velocity will be constant, right? So there is no acceleration in uniform motion. So the line will be the x-axis. X-axis will be the curve in acceleration time curve for uniform motion. And in non-uniform motion, the acceleration will be like this in this curve. It may be uniform acceleration or non-uniform acceleration. So here, if we find slope at this point, this will be theta, which is equal to we cannot find any slope here. We can find, but there is no need other. So in the last curve we have seen acceleration is equal to dv by dt. dv is equal to a into dt. V is equal to integral A into dt. Since we study up to only rate of change of velocity, we are not finding any slope here. So we have seen rate of change of displacement is velocity and rate of change of velocity is acceleration, and we do not study about rate of change of acceleration. So here area under acceleration time AT curve gives velocity. Since here it is A into dt, right? This is A and this is dt. If this area is elongated from t1 to t2, it will give the velocity since it is v. So problems can be asked from this next section, motion with uniform acceleration. If it is traveling with a uniform acceleration, it will be like this. The curve for uniform acceleration. So sorry, this is in the curve. The curve will be ignore this. If this is acceleration and this is time, the uniform acceleration will be like this. Okay. So in uniform acceleration, motion with uniform acceleration, acceleration can be given by v minus u by t. Since the motion is uniform, the acceleration, the velocity increases gradually with respect to time. So it is v minus u by t. It can be written as v is equal to u plus at. We have seen that displacement divided by time is average velocity. So here s is equal to u plus v divided by 2. Since it is uniform acceleration, we can write u plus v by 2 into t, and s can be given by, here it is u plus v by 2 and v is u plus at. Substituting this v in this, we get u plus at divided by 2 into t. So we get ut plus half at square. And from this we get time as v minus u by a. And in distance, s is equal to u plus v by 2 into t, right? U plus v by 2 into t into the time is v minus u by a. So from this we get v square minus u square is equal to 2as. If you tabulate these three equations, these are important equations. V is equal to u plus at, s is equal to ut plus half at square, v square minus u square is equal to 2as. So here v is the final velocity and u is the initial velocity, and s is the distance traveled by the body, and t is the time taken to travel distance s, and a is the acceleration with which the body is traveling. So if it is asked to find in nth second, which means if a body takes 4 seconds to travel from one point to another point, if it is asked to find what is the distance traveled in third second, so we apply this formula. Sn is equal to u plus a by 2 into 2n minus 1, where n is the second which is asked. In this case it is third second, right? So n is 3. This is in case of bodies traveling in horizontal direction. If it is in vertical direction, that is, if the bodies travel under the action of gravity, then how does these equations become? if a body is thrown upwards, it should be thrown with an initial velocity, some initial velocity u. After it reaches a final velocity v, which is 0. If we consider at the highest point, it will be 0. So velocity is gradually decreasing. So sorry, the velocity is gradually decreasing, right? So acceleration will be negative. Why acceleration is negative? Acceleration is increase in velocity, and decrease in velocity is called deceleration, and it is represented with minus sign. So v is equal to u plus at, we have seen in this. V is equal to u plus at, and here a is minus g, right? So v is equal to u minus gt. H is and we take the total distance traveled is h, height of the body up to which it is reached. So h is equal to ut minus half gt square. V square minus u square is equal to 2gh. When the body is dropped, if it is just dropped, the initial velocity will be 0, and the final velocity will be on touching the ground will be v. So v is equal to ut plus half at, right? Sorry, ut plus v is equal to u plus at. So u is 0 here, and the velocity from 0 it is increasing up to v. So it is accelerating. The velocity is increasing, which means it is acceleration, not deceleration. So a is equal to plus g. V is equal to u plus at, right? Here a is g and u is 0. So v is equal to gt, h is equal to half gt square, and v square is equal to 2gh, since u is 0. If the body travels with varying acceleration, if the acceleration is varying, then v is equal to ds by dt, right? And a is equal to dv by dt. Rate of change of velocity is called acceleration. If it is uniform, if acceleration is uniform, then acceleration is equal to v minus u by t. And if it is non-uniform, acceleration will be dv by dt. So this we have seen in the starting of the chapter. V is ds by dt, and it can be written as v into dv by ds. Let us see a problem in this. Given that a particle moves from a point O with velocity v is equal to 3t square minus 60 plus 3, and that expressions t is equal to 1, s is equal to 2 meters. Find the expressions for acceleration of the particle, displacement of the particle in terms of t. So it is given that v is equal to 3t square minus 60 plus t. Here v is given 3t square minus 60 plus 3. So as the time increases, velocity is increasing. So the body is traveling with an acceleration, right? It is asked to find acceleration of the particle. So acceleration is given by rate of change of velocity. So dv by dt is acceleration, right? If we differentiate this v with respect to t, 3t square minus 6t plus 3, it will give 3 into differentiation of t square is 2t minus 6 differentiation of t is 1 and plus 0. So acceleration is equal to 3 to the 6 t minus 6. This is the first one, and this is a. And what is b? The displacement of the particle in terms of t. Displacement. So displacement is given by rate of change of displacement is velocity, right? So displacement can be given as integration of velocity in terms of t. So displacement can be given by integration of what is velocity in this question, 3t square minus 6t plus 3 dt. So integrating this, 3 into t square, integration of t square is t cube by 3 minus 6 into integration of t is t square by 2 plus 3t plus arbitrary constant c. So this is 3 gets cancelled, 2 3 times gets cancelled. This is displacement, s is equal to t cube minus 3t square plus 3t plus c. This is the displacement. So at t is equal to 1 and s is equal to 2, in order to find this arbitrary constant, we substitute t is equal to 1. When t is equal to 1, s is equal to 2. So after traveling a distance 1 second, the displacement will be 2 meters. So s is 2, right? 2 is equal to 1 cube minus 3 plus 3 plus c. 3 gets cancelled and c is equal to 2 minus 1, which is 1. So s will be t cube minus 3t square plus 3t plus 1. This will be s. Until now we have seen linear motion, right? In curvilinear motion, the body travels in a curve. This is called curvilinear motion. And suppose if it travels from here to here, if this is theta, right? This theta is called angular displacement, and rate of change of angular displacement is called angular velocity, which is d theta by dt, and it is represented with omega. And angular acceleration is rate of change of angular velocity is called angular acceleration and represented with alpha. The tangential velocity, what is tangential velocity? If we consider at a particular point here, angular velocity is in this direction and tangential velocity will be in this direction. In this direction, what will be the velocity? It is called tangential or linear velocity. So it is given by this radius. This is r into angular velocity at this point. So it is called tangential or linear velocity. See, same like linear motion, the curvilinear motion has equations. These all 4 equations. Final angular velocity is equal to initial angular velocity plus angular acceleration into time. This is angular displacement. Angular displacement is equal to initial angular velocity into time plus half into angular acceleration into time square. And this is final angular velocity square minus initial angular velocity square is equal to 2 into angular acceleration into angular displacement. And this is angle turned in nth second. It is given by this formula. And next one is projectile. What is a projectile? If a body is projected and not traveled in horizontal direction, if a body is projected in incline, or if a body is projected horizontally from a top of building, then it is called as projectile. So body can be projected from the ground or from any top of building or anything like that. So if a body is projected at an inclined at any inclined direction, then it is called as inclined projection. And if body is projected horizontally from any top of building or a rock mountain or something like that, it is called as horizontal projection. So let us see inclined projection first. Here the body is projected in the inclined direction with an angle alpha, and it travels up to a height of h, and then it falls down onto the ground. The distance traveled on the ground is r, and the distance traveled maximum height is called h. And in this, the horizontal direction is u cos alpha. This is u cos alpha, and the vertical velocity is u sin alpha. Here u cos alpha will be always constant along this total path, but u sin alpha is not constant because gravitational force is acting on it. Up to here the velocity decreases, and from here to here the velocity increases. So what are these? The path traced by this projectile is called trajectory. So equation of trajectory is given by, we have seen that h s is equal to ut plus half at square, right? And in here u is u sin alpha, and if we consider it as a vertical one, vertical velocity, if we consider vertical velocity, initial velocity is u sin alpha and time is t. Here we can see it travels with decreasing velocity, so it will be a will be minus g, so it here it is minus half g square. This is the equation of trajectory. If you consider it a particular point P, and it is traveled with distance x here, and the height will be y. If you consider at that particular point, to reach distance x, it will be x u cos alpha into t, because velocity is given by distance by time, right? Here I have said that the horizontal directional force will be constant throughout this path. The horizontal directional force is u cos alpha, and the distance traveled is some x divided by t. So x is u cos alpha into t. And t will be x by u cos alpha, and y is equal to, if we substitute t value in this, we get this equation. So these two are equations of trajectories. So what is the height reached? The maximum height reached is u square sin square alpha divided by 2g, and range is u square sin 2 alpha divided by g. And time of flight, what is time of flight? The time the projectile is staying in the air is called time of flight. It is given by 2u sin alpha by g. And maximum range, this is the range, right? The maximum range is the one which, if it is thrown with a velocity u, and it is thrown with different angles, the maximum range will be when it is thrown with an angle of 45 degrees, because in this r value u square sin 2 alpha divided by g, right? In order to be range maximum, sin 2 alpha should be maximum. For sin, the maximum value is 1, right? So when will be the sin 90 will be 1, right? So 2 alpha is equal to 90 degrees and alpha is equal to 45 degrees. So maximum range will be u square by g when alpha is 45 degrees. So in horizontal projection, if a body is projected horizontally from a tower with height h, it travels in this path from A to B. So h is equal to ut plus half, sorry, s is equal to ut plus half at square. And if we consider in here, if you consider the vertical motion, the height traveled by the body is h, and the velocity with which the velocity is in the direction, the initial velocity is in the direction horizontal direction. So the no velocity is applied in this vertical direction. The body is moving downwards only with the gravity. So h is u is 0, the vertical initial force will be 0 and into time plus half gt square, because it is traveling downwards. The acceleration will be positive, the acceleration due to gravity will be positive. So h is half gt square and t is under root 2h by g. This is time of flight for horizontal projected body. And what is range? Range is equal to u into t. So s is equal to ut plus half at square, right? Here range is r, and horizontal velocity is totally u into t plus half into, is it traveling with an acceleration in horizontal direction? No, it is, the velocity of this body is constant everywhere over the path. So acceleration is 0 into t square. So r is ut, this term will become 0. And the velocity with which the body is hitting b, the vertical velocity with which the body is hitting b is g into t. Resultant velocity will be under root u square plus v square, because the body has horizontal velocity and vertical velocity. So the resultant velocity will be under root u square plus v square. And if it is hitting at an angle theta, the theta is given by tan inverse of v by u. Let us see a problem in this. See here, a rocket is released from a jet fighter flying horizontally at 1200 km per hour at an altitude of 3000 meter above its target. So the rocket thrust gives it a constant horizontal acceleration of 6 meter per second. At what angle below the horizontal should pilot see the target at the instant releasing the rocket in order to score a hit? So what he is asking to find us, this is the land. Suppose there is a point here, this is B, and the rocket there is a the jet is flying at a distance of 3000 meters, flying at a height 3000 meters above its target. The target is here, and the height will be 3000 meters. This is 3000 meters. And if the rocket is projected horizontally, the rocket is Actually it is just dropped, but this has an velocity of u is equal to 1200 kilometer per hour, and it travels in a trajectory path like this. So he is asking us to find, in order to fire here, in order to reach this rocket here, what is the angle that should be made with horizontal, with what angle should the pilot see in order to fire at B. He is asking us to find that. And any data, other data is given here. So the initial velocity u is given as 1200 kilometer per hour, which is in horizontal direction. 1200 kilometer per hour. So 1200 into, let us convert it into meter per second first. Kilometer, 1 kilometer is equal to 1000 meters, divided by 1 hour is equal to 3600 seconds. 2 zeros cancels, and 12 hundreds, 12 threes are, this will be 333.33 meter per second. And another value given is h is equal to 3000 meters, and another one is acceleration. The horizontal acceleration is 6 meter per second square. In the theory section we have seen that if a body is projected horizontally, it travels with a uniform velocity in horizontal direction. But here it is given that the rocket has horizontal acceleration. The thrusters of rocket will be accelerating the body. So horizontal acceleration is 3 meter per second square. So what we need to find? Theta, angle theta. Angle theta can be given by, this is theta and this is the triangle. So theta can be given by tan inverse of opposite by horizontal. The horizontal is range, the vertical is height. So tan inverse of opposite side is height divided by horizontal, adjacent side is range. So we get but we don't know r, right? We need to find r. In order to find r, it is the horizontal one, right? So we know s is equal to ut plus half at square. So here the distance traveled, s is r, range, and initial velocity is there, u into t plus half into at square. If it is not moving with any acceleration, then this will be 0, but it has an acceleration of 6 meter per second square. So range will be r is equal to, do we know initial velocity? Yes, we know, which is 333.33 meter per second into, we don't know the time, and plus half, we know acceleration, which is 6 meter per second square, t square. In order to find t, we take h. H is given by ut plus half gt square, right? Ut plus half gt square. The rocket is just dropped, and so initial velocity will be 0 in the vertical direction, half gt square. Initial velocity will be 1200 kilometer per hour in horizontal direction, and in vertical direction it will be 0. So from this we get 3000 meters is the height is equal to half into 9.81 t square. So t will be, if you calculate this, we get 24.73 seconds. In 24.73 seconds it can be reached to the point B. And if we substitute this 24.73 in this equation, so R is equal to 333.33 into 24.73 plus half 6 into 24.73 square. So we get R as R is equal to 10,078.5 meters. So then theta will be tan inverse of h divided by r, right? So tan inverse of what is h? 3000 meters divided by r is 10,078.5 meters. We get theta is equal to 16.576 degrees. This is the theta, which means the pilot should see at an angle 16.576 degrees in order to fire at B. Let us say this way, from point A he should see at an angle 16.576 degrees with horizontal in order to fire at B. So this is how we need to solve this projectile problems and the problems based on linear motion and curvilinear motion. So if this video is helpful for you, please like, share and subscribe to this channel. Thank you.